Hi, welcome back to our Algebra 1 video series. On this video, we're going to talk about how to factor a trinomial with a leading coefficient, or a trinomial that has a number out front of the x squared. So we're so used to seeing problems like this one, where I would split up my trinomial into the x terms and the constant, and I would figure out what two numbers multiply to the constant, so 1 and 12, 2 times 6, 3 times 4, and what pair adds or subtracts to a negative 8. So I see here that I need to add or subtract to a negative 8. Well, the two numbers I could add or subtract to 8 would be 2 and 6. So maybe I could have 2 plus 6. That would be positive 8, but I want negative 8. So that doesn't work. 2 minus 6 would be a negative 4, so that doesn't work. Negative 2 and a negative 6 would make 8 negatives, so that would work. So my final answer would start with x and x, and I wanted 2 negatives and 6 more negatives to make 8 negatives. And that's how I would factor a trinomial with no number out front. But if I had a number out front, what I would have to do is first I would divide out a greatest common factor if that's possible. Like here, I've got 3 even numbers, so I could divide out a 2 and make that a little bit easier. But unfortunately, I still have a leading coefficient, a number out front. Now sometimes we would get lucky. Sometimes I would get a problem like this one, like number 7, where I've got 5 and 20 and 20. I can divide out a 5 from all 3 parts, and I would get x squared plus 4x plus 4. And now this is something that we know how to factor, right? And if you're not sure how to factor that, you can watch some of my other videos on how to factor a trinomial where a equals 1. But here again, I would find the numbers that multiply to the constant 4 and add to 4. So I would have x plus 2 and x plus 2, and I have to remember that 5 that I divided out initially. So sometimes we'll get lucky where I can divide out a leading coefficient and I would be left with no leading coefficient. I already know how to factor those. But if I'm not given a problem like that, if it doesn't factor out nicely, then what I would have to do, I've already divided out a GCF. So step 2, I would need to split b into 2 factors. So I'm going to multiply a times c, or the first term times the last term, to make 36. And I'm going to list out the factors of 36 here. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. And I need to figure out what terms here would add or subtract to the middle number of 13. So that doesn't change. I'm still finding factors that add to the middle term. 1 plus 36 would get me 37, so that does not work. 2 plus 18 gets me 20, that does not work. 3 plus 12, we're getting closer, that's 15, still doesn't work. 4 plus 9 would get me 13, that's what I wanted. I want 4 plus 9. So I want 4 positives and 9 more positives to make 13 positives. And once I've identified what two numbers to use, I'm going to rewrite this. So I'm going to write 3x squared. And now this 13x, I'm going to split that up into 4 and 9. So 13x, let's call that 4x and 9x. So I can say 13x written as 4x plus 9x. So notice that the only difference between my original equation and this one, or my original expression rather, my original polynomial, and this altered polynomial, is that I just split up 13x into 4 plus 9. But it's still 13x. It's just a different way of expressing it. So that's step one. Find your factors of AC that add to the middle term and then split that middle term up. And once I've split that middle term up, now we're going to go back to our GCF, our greatest common factor. We're going to break this up into two halves, and I'm going to find the greatest common factor of each half. So going back to our greatest common factor videos, I know how to find a greatest common factor. So I need to know what goes into 3 and 4. That's 1 and 3. That's 1 and 4. And 2 and 2. And the only thing they have in common is 1. So the only thing I could divide out of both would be a 1. So this greatest common factor is a 1. I have x to the second, x to the first, so it'd be x to the first is the smaller of the two. And I'm going to take each part here and I'll divide it by the greatest common factor. So just like before, we're dividing out a greatest common factor. And I'm going to ignore everything on the right there. So 3 divided by 1 is 3. I had 2 x's. I divided away 1, so I'm left with 1x. I see a plus sign next. 4 divided by 1 is 4. I had an x. I took it away, so I have no x's left. So all I've done so far is I split up the middle term into two parts, 4x plus 9x. And now I'm just finding the GCF of each half of my polynomial. So the greatest common factor of 9 and 12 would be 3. That's 3 and 3. This is 3 and 4. So greatest common factor there. And this has 1x. That has no x's. So the smaller number would be no x's. So my greatest common factor is a positive 3. So I'll put positive 3. And I'll divide each part by 3. 9 divided by 3 is 3. Keep my x. 12 divided by 3 is 4. So what we've done so far is I took a times c, 3 times 12, and I found out what factors of 36 would add to the middle term of 13. Once I had that, I split up my middle term into 4x and 9x. And I found the GCF of each half of my polynomial, and I divided that out. Now my final answer, how I will express this, I'm still going to have two sets of parentheses. One set of parentheses will be what's inside my parentheses after I divided out the GCF. So notice that both of these are the same. That's good. If they're the same, I did it correctly. If they are not the same, I've made a mistake somewhere, and I can go back and check my own work. But here, 3x plus 4 would be one of the sets of parentheses in the final answer. The other set of parentheses would be what was outside the parentheses. What was my GCF from each part? That would be 1x and a positive 3. Let's try another example. Again, I see a number. I can't divide out anything from these three terms, so I'll have to take a times c is 12, 1 and 12, 2 and 6, 3 and 4. I've got to find out what pair adds or subtracts to a positive 8. So 1 plus 12 would give me 13. 2 plus 6 would get me 8. 3 plus 4 would get me 7. And it looks like my winning pair is 2 and 6. 2 positives and 6 more positives to make 8 positives. And I'll rearrange this 3x squared plus 6x plus 2x plus 4. Now it doesn't matter what order you put these in. I could have put 2x plus 6x. As long as you have 2x and 6x, the order there does not matter. You can switch those two around. right? Because 6 plus 2 is the same thing as, if I were to write this as 6 plus 2 is the same thing as 2 plus 6, so it doesn't matter what order I put those in as long as I've got both parts. And now I'm going to split this up into 2 halves, and I need to figure out what my greatest common factor is. Looks like it's 3x there, and on the right it looks like it's 2. So I'd like you to try and unpause the video, divide out both parts, so divide out your greatest common factor from both parts, and then see if you can get your final answer, and then unpause when you're done to check your work. So if I divide out my greatest common factor, 3 divided by 3 is 1. I had 2 x's, I took 1 away. 6 divided by 3 is 2. I had an x, but I took it away, so I have no x's. 2 divided by 2 is 1. 4 divided by 2 is 2. And I know that I'm correct, or at least I'm on the right track, because my 2 sets of parentheses are exactly the same. Now when I write my final answer, 1x plus 2 is in those parentheses. That's going to be half of my answer. The other half of my answer is what's outside the parentheses, the 3x and the plus 2. All right, I'll help you get started on the next one, and then I'll give you a chance to finish that on your own. So 6, 16, and 8. I could divide a 2 out from all 3 parts. So then I'll do 3 times 4 is 12. And then I need to find out what 2 numbers would multiply to 12 and add or subtract to 8. So 1 and 12, 2 and 6, 3 and 4. Why don't you pause the video, try to solve this one on your own, and then unpause and check your work. All right, so if I factor this, I get 2 and then 3x squared. I should have chosen 2 and 6 to make 8, plus 6x plus 2x plus 4. So then if I 2, and then I'll take out a 3x, that would be 1x plus 2, and I can divide out a GCF of 2. And if I divide out a greatest common factor, whatever number I divide out should be out in front of those parentheses. So the greatest common factor would be out in front of the parentheses, just like it always is. 2 divided by 2 would make a 1x. 4 divided by 2 would make a 2. Now a quick reminder that we have to keep that 2 out front. That's still there. And now if I were to simplify this, I'll keep that 2. So I'll keep the 2. And my 2 sets of parentheses, inside was 1x plus 2, outside was 3x plus 2. Now it does not matter what order those 2 sets of parentheses in. I could have 2 and 3x plus 2 times 1x plus 2. It doesn't matter how you arrange these two, as long as those are your 2 sets of parentheses. Now let's zoom out a little bit. What's going on here? Well, 2 and 4 were multiples of each other. So from 2 to 4, all I did was I multiplied by 2. So 3 became 6, 8 became 16, 4 became 8. And that's reflected in our answer here. This is the same as the one that we just did. The only difference is I multiplied by 2 on the outside. Let's try one more Let's try one that doesn't have a GCF. Let's try this one. So you gotta do 5 and 8, 40. Numbers that multiply to 40, add to 14, 5 and 8. Why don't you pause the video, factor this one, and then unpause to check your work. Now it does not matter what order you put the 10 and the 4 in, as long as you chose 10x and 4x. Your greatest common factor would be a 5x there. That would be 1x plus 2. Your greatest common factor for the second half would be a positive 4, and you would get a 1x plus 2 again. And I know that I'm correct because my two parentheses are both 1x plus 2. So I get 5x plus 4 and 1x plus 2, and that's how I could classify that one. Now, I could just kind of check one last time to see if there's anything that I could divide out of both. You know, is there any number that I could divide out of 5 and 4? No. Is there any number that goes into 1 and 2? No. So that means that I am completely factored, but not necessary to do that if you remember to check in the beginning if there's any number that you can divide out of both parts. Let me know what questions you've got, and I'll see you later.